Today, I want to talk about a workflow that's going to let you use Vim in the terminal as your primary dev environment. So, this works for most languages from C++ to Ruby to things like Rust or JavaScript. And the goal is to keep it the same across all the platforms, so Linux, Windows, and Mac OS. We're going to start with a small project, a single file, a single compilation unit, and I'll show you how it scales up to a bigger one. The structure of the video is going to be we'll go through each individual topic from aesthetics to Vim to everyday terminal usage to the fix run workflow inside of Vim to debugging. And then at the end, I'm going to have a list of all the repositories and tools and config files in one public gist that you can refer to. So we'll go through each of those things and then you can have the document to refer to. There's going to be a lot of content, and I'm not expecting you to learn it all, but rather to know that it exists and therefore see if it's something you want to adapt into your workflow or not. So we'll start off with aesthetics. So that's basically the number one comment I've had on videos like this is like, why does your terminal look like that, etc. This is basically two things here. One is a color scheme. It's a color scheme called this one's called Dracula, and it's draculatheme.com, I believe. And it supports something like 1,200 different tools, et cetera, et cetera. It's very popular, and therefore there's less bugs, and it works on all the platforms, and it's not so screwy. So that's the main reason I use it, and you can check it out. I use three config files: one for Vim, one for the terminal itself, and one for tmux, which is a terminal multiplexer. So they're relatively straightforward to install. Don't need to spend too much time on that. The other piece is the font. So I'm using Code. It has ligatures in it. If you're unfamiliar with ligatures, it basically just means you have multiple characters that create one glyph, and they're usually things that are useful to programmers, like these symbols. Some people hate them, so do whatever you want. It's not a big deal as far as the workflow goes, but it does make it nicer if you have a nice monospace programming font. So that's the aesthetics of it. The next thing I want to talk about is just everyday terminal usage. So what do I use on the day to day? And it's basically something like three commands, and they're mostly focused around moving around a directory structure. I'm relatively competent at bash programming, but I don't do that much of it. So day to day, it's really just getting around and running commands and then running them again and again and again. So the way that I do that, one tool is reverse bash history. So up arrow, obviously, most people know in a terminal setting, usually gives you the last commands you've run. Um, there's a small improvement on that, which is actually searching based on a substring. And so you hit Control R and Bash to do this. There's probably an analogous function in Z Shell. Um, this really changes the workflow quite a bit because if you have a complicated compiler string with a bunch of arguments on it, or a test library that you're running, or you're adding firewall rules, some of that stuff you got to do repetitively until it works. And this is one of the best ways to be able to recall long strings of stuff. So yeah, that's it. The next thing is a fuzzy cd tool. So if I print the working directory here, go to my home directory. If I want to go back, I have to type dev/scratch, and then I hit tab for tab completion, LC. That's pretty short, but paths can get really long, as we know. So Z allows you to do a substring match on a directory, and it learns over time where you go and will weight the path based on the frequency that you go there. So ZLC takes me right there. Just a really handy tool. I'm going to link the repository to this thing. I think it was originally developed for Z Shell, but it's available and works in Bash as well in a repository on GitHub. The next thing that I use every day is a terminal multiplexer. And in your workflow, you can favor the native terminals, windows, and tabs. They do exactly the same thing I use it for, though tmux can do a bunch of other things. I just don't generally use, I use a very small subset of each of these tools to get some very specific task done. I'm not an expert in each of them. So in this case, you can use tabs and, splits in your native window terminal to do the same thing. I do it like this because it keeps the uh, keybinds the same across platforms. So for me, it works. I'm in a tmux session right now, so I'll detach. This is what it looks like normally. I can list the sessions that I have active. You can have more than one session, so therefore more than one project that you're working on, and you can attach to those sessions, and it will save your environment, which is kind of nice. I don't really do that often. I do detach and attach from one session kind of often. So down here at the bottom, you can see the status bar. That's tmux, and it has two windows open, a 0th window and a first window. Both are pointing to bash right now, but you can imagine if I have one open on Vim, the second one can be pointed to the terminal. So it's a very quick way for me to switch between um, those two contexts. Uh, there is a leader key associated with tmux. The leader key from me is Control A. You can see there on the screen is this little keystroke thing. And then N switches to the next window or toggles to the next window. So that's basically the extent of the commands that I use all the time for it is switching between 2 or 3 contexts. So no big deal there. I do every once in a while need to create or kill a window or split a tab. If you hit the leader key, then colon in the same way that you interact with Vim command mode. You can type new window here and it will create a third one here. You can type kill window and there's tab completion and it will kill it. So those are the extent of the commands that I use every day for my everyday terminal stuff. Next thing I want to talk about is Vim itself. Um, I'm not going to convince you to use Vim. Hopefully, you've already thought that this is a good idea, and this is why you're investigating this video. My promise is to show you the core set of motions that I use every day in programming, and then expand around that core a little bit, give you kind of a nugget that you can expand knowledge from in concentric circles. I maybe have like a half dozen things that I do on the regular, and I think it just those half dozen things makes a huge difference in terms of your text editing capabilities. Even if you're taking this into a different text editor like VS Code, there's Vim emulation modes in those almost every text editor these days. It's popular with programmers, so I highly recommend it. The first thing is the smallest possible movement in Vim, which is just moving around. You can use your arrow keys. It's totally fine to do it. I'm not like a zealot about this, but the Vim way is to use HJKL for your arrow keys for moving around one character at a time. And this allows you to keep your hands on the home row of the keyboard without moving around. And once you learn it, it's like slightly more efficient, which is kind of nice. It's like, you're not moving all over the place, getting your mouse or going over the arrow keys and things like that. So I use that for the smallest core movement in Vim. The next thing is you move up to the next level, which is like medium-sized movements. The medium-sized movements that I use are really page up and page down. I don't know what the real names of these are, but it's Control D and Control U, and they take you up and down through the file, some chunk, some sort of page level move. And then the biggest move that I make is Shift G takes you to the bottom of the file, GG, lowercase g, takes you to the top of the file. So those are the sort of moving around the file moves that I use on the regular. The only other one that I do very occasionally is if I want to go to a specific line, you can type colon and then a number, and it will take you right to that line number, which is kind of nice. But the other ones serve me, I'd say probably like 80% of the time. It's like you want to get the smallest number of commands down pat that are going to get you the largest percentage of the way there to be efficient as quickly as you possibly can. And then from there, sort of expand out your command um, armamentorium or whatever. I don't know, some word that describes your arsenal of tools within the editor. Then we take it one step further and we say, well, okay, I want to move within a line. So how do I do that? The most basic way is HJKL. Again, if you're moving around, no big deal. But if you hit W, it takes you word by word, which is kind of useful. And then the other one that I use is forward, F. So F will take you to the next instance of a given character. So if I type left caret or left arrow or whatever, it'll take me there. If I type capital F, it'll take me to the most recent character behind you of that type. So if I type open paren, it'll take me back there. That's how I move within a line, full stop. That's all the movement that I use in Vim. There are a million other ways to move around, but I don't know. At a certain point, there's diminishing returns for learning all these motions. So I try to find, the smallest subset that works for me. Next thing I want to talk about in Vim is sort of destructive editing. So this means like replacing a word, for instance. So the way that I do that 90% of the time is cut in word, CIW. CIW will take away the word that your cursor is currently on and put you in insert mode so you can replace it with something else. So function name, whatever. So it's very useful, and you do this in programming all the time. The other thing about these cutting motions or destructive motions, they really do cut. They put it into Vim's internal clipboard, which is called a register. You can hook that internal clipboard up to the system clipboard as well, but it takes a little vimrc, the vim config file magic to make that happen. It's slightly different per platform, but I highly recommend it. I'm a huge fan of being able to integrate the system clipboard with the vim clipboard. So if you're copying and pasting from some Stack Overflow site or something along those lines, or pasting a error message directly into your web browser, you're not fumbling around trying to figure out which hotkey you need to use to copy and paste, because in a terminal setting, Control C and Control V are generally not the default key bindings for copy and paste, though they are apparently in Microsoft Terminal, which is a little weird because foreground, SIGINT, and Vim visual mode are both associated with both of those. So generally not a huge thing, but a lot of times it will be Control Shift C to copy, Control Shift V to paste, or sometimes it'll just be select it with your mouse, things like that. But in general, if you integrate the Vim register with the system clipboard, you don't have to screw around with that. You can yank stuff or cut stuff into the clipboard, and it will go directly into your clipboard, and so forth and so on. So with that out of the way, when you do one of these destructive cuts, cut in Word, you can paste it with P as the most basic motion. P will put it right under your cursor. Shift P will do a slightly different behavior. I generally use either Shift P or P. I can't even describe what they do. It's like either one character forward or one character back. You kind of get it by touch and feel once you figure it out. So what's the next destructive cutting motion that I use all the time? It's essentially cut inside matching punctuation or matching symbolic. I guess it's punctuation. I'm not really sure what it is, but it's things like braces or parentheses or open carets. So in this case, if I want to change the arguments of this function, I would say cut in open paren, and it will kill everything inside that open paren. It puts it inside the system clipboard for you to paste if you need to take it somewhere else. But in general, if you're going to do something different, you might do something different like this, and then you can cut it again, whatever you need to do. So that works as well as inside of function braces. So if I do CI and then open brace, it will kill everything inside this. These are really useful for programming. There's another use case for it. If you have a longer string and it's a string literal of some kind, if you do CIW, it's going to cut the one word. If you want to cut the entire string and replace it with something, you can do CI and then quotation mark. And there you go. You've got your string all done there. So the first one is really cut in Word, and then you can kind of expand your arsenal as you need more stuff, or you have more willpower to memorize more of these commands over time. I suggest going for the cut inside braces or cut inside paren or cut inside quote is the next thing you go for. So the next thing is sort of non-destructive editing or non-destructive text selection. It's really about Vim visual mode. So the really basic nugget of Vim visual mode is Control V. This lets you select some text based on normal motions in Vim, and then when you're done, you can hit escape, for instance, or you can do something with it. So in this case, let me say I want to copy this piece of text. I can hit Y to yank it, and then later on I can hit P to paste it somewhere, whatever I need to do. And that's the equivalent of selecting text in every other text editor known to man. The difference is there's some more specific commands. Once you've got the Control V thing down, the golden nugget inside of text selection, you can go for some more specific stuff. Shift V will select an entire line. You can yank that and then paste it on the next line in that way. This is good because you can also use the up and down arrows or HJKL to move your selection to be a bigger thing. And then you can paste an entire thing somewhere else. This is something you do in programming all the time, obviously. So you can also use visual mode, just like I just did, to select a line. You can hit D and it will delete that line. There's some shortcuts to that motion, but that's like the most basic way. Select the line with Shift B, hit D to delete it. And by the way, it's inside the register, your yank register, so you can paste that later if you need to. If you're moving something, like if I want to take a declaration and move it down, that's how I do it. So you've got Control V now and Shift V in your arsenal. There's one more thing that you occasionally have to do that's like slightly more efficient, and that's selecting a word. So in the same way that cutting a word is CIW, selecting a word is VIW, visual mode. IW. I don't know what it stands for, but yeah, there it is. So you can yank that word and then later paste it as you need to. So it's slightly more efficient than hitting Control V, selecting the whole thing, and then yanking it. That's it for visual mode. I don't touch anything else there. There are some other uses for it, like editing things in a column and all that kind of stuff. But it's relatively advanced. You don't really need it off the top of your head. There's other ways to get things done in Vim without knowing all that goofy stuff. So with destructive editing and text selection out of the way, we can take a look at the next thing I use all the time, which is just basic search. So in Vim, you use the / on the keyboard to start a search, and then you start typing. In this case, let me see. I'll type some. It's going to highlight because I have in my vimrc, my vim config file, I have a search highlighting on, and I hit enter to sort of execute the search. Even though it does, I believe it highlights it on the fly. No, it doesn't. So if I hit some to execute the search, I hit enter, and I can hit N, and it switches between them. You can't actually see my cursor because this particular terminal I'm using, the cursor is staying as a bar there. But in general, there it is. If you hit N again, it cycles through from the bottom all the way down. Um, a subsidiary thing here. So if you hit /, normally the next thing people ask about is search and replace. This is a little bit goofy in Vim. In my opinion, it's like one of the harder things to remember when you're brand new to Vim. But it's very similar to searching, and it's very similar to regular expressions if you're familiar with that stuff. So what you do is use colon, then %s, then /. That's the start of it. This is like the preamble to it. And what we're saying to Vim in command mode is, I want to look for this word, some, and I want to replace it with this word, some2, let's say. And /g says it's global across the whole file. I hit enter, and it replaces everything there. You can combine that with visual mode selection, which we just learned, like this. I have all this stuff selected. Let me select just a little bit of it. Hit colon, and those special characters that appear ahead of the colon there mean go from the start of the selection to the end of this selection. You hit S for the same thing, search and replace. If I replace some here with some2, it's only going to replace this stuff inside of my selection. And you'll notice it didn't replace the thing up here. I'm going to turn off highlighting for a second, which is colon no H, just to get rid of that stuff to show you that this is still some, and these are some too. So I'm going to undo that stuff I just did with U, save it. So the next thing is, and arguably this should have been at the beginning, but I kind of like the destructive cutting stuff to be at the beginning because it shows you the power of what you're getting yourself into. Vim has however many modes, I don't even know how many, but the ones you're most concerned about are normal, insert, and visual mode in general, as well as command mode if you're typing some Vim command. But normal mode obviously doesn't let you edit the text until you get into insert mode. You do that the most basic way. The golden nugget in the center of it is hitting I, and that takes your current cursor position and enters insert mode right there. So I can now type, and it's typing and editing the file. Once you get that down, there's basically 4 other ways that I use 4 other key bindings essentially that get you into insert mode in slightly different ways that are slightly more efficient, but they are super helpful to have. The first one is Shift I, which takes you to the beginning of the line you're on. The second one is Shift A, which takes you to the end of the line you're currently on. So those two are sort of symmetric in that way. Beginning of the line, end of the line. The next two are symmetric as well. Little O takes you to the next line and inserts a new line character and takes you to the same indentation level in your source file, regardless of language. I forget which setting in the vimrc is particularly associated with indentation stuff, but it might even be on by default. You hit little O, it takes you to the next line, puts you in insert mode. Shift O takes you to the previous line, inserts a new line character, and puts your cursor right on the first column in that indentation row as well. So that's it. Full stop. That's what I use to enter insert mode, generally speaking. So little I, that's the golden nugget. The concentric circles around little I are Shift I to take you to the beginning, capital A to take you to the end, little O to take you to the next line, big O to take you to the previous line. That's it, really. So those are all the motions I use. And just that stuff makes me extremely productive generally speaking, compared to other keybind systems or something that's very vanilla in some other text editor. So it's actually an extremely small subset of what Vim's capable of. And I'm sure over time I'm going to pick other stuff up. But, you know, you only have so much brain power to dedicate to tools every hour of the day. So this is the subset of the tool that I'm using that's made me more productive. The only other things in Vim that are like vanilla things that I used every day are saving a file, quitting a file, and editing a new file. So :W saves a file, :Q quits the file, :E edits a different file. So those things all, um, those are the basic Vim commands that I use every day. So moving along, now we're in Vim. We can move around and edit the file. That's great. So how do we get productive in terms of actually compiling code, and what does the compile fix run workflow look like? My promise is that you'll stay inside Vim. You're going to be able to jump to compiler errors by a file number and line number, or file name and line number, and you're going to be able to run the binary or the interpreted script, whatever you would have you from inside Vim, and pipe the output back into a nice little buffer at the bottom of the screen, so you don't have to leave the context of the file if you don't want to. So we do that through one big thing. It's called the quick fix list. You can use that as a Google thing if you want to go research this yourself. It actually has a lot more features than I'm going to go through. But again, I'm going to give you the golden nugget in the center in terms of what you need to do to get successful. So the quick fix list is essentially a way to show compiler errors or interpreter errors or VM errors or whatever it is in the language that you're looking for. And it takes that compiler output, parses those error messages, and allows you to skip between the errors based on the file name and the line number of the error. And it does that in a way that's relatively automated and from a Vim perspective. So the way that I get that done is if we start based on the compiler options that I'm using. Let me show you what they are here. So for instance, I've got a Clang option here, and I've got G++. We've got G++, which is just GCC with the standard library link to it, set up here. And what this does is it's just a standard compiler string with a bunch of options associated with it for building one file, in this particular case, with two special things. It's got this little percentage with a little caret on it. This is the file name without the extension. And then this one is the file name with the extension, test.cpp. So this -o specifies the build output, which is going to go to the build directory and be called test. The binary is going to be called test. And then this one's called test.cpp because it's the file we're compiling. This make prog variable here, if I just edit this vimrc file, is the thing that our internal function inside Vim uses to do its compilation process. It pipes it out to the terminal, pipes it back in, and parses it. So this is sort of the center of it, if you will. And as we scale up, I'll show you how to use this with CMake, for instance, for using it with a bigger project. But in general, this is the kind of core of it. Now, how do I get project-specific vimrcs, you might ask? So vimrc is the config file for Vim. If I go to my home directory and show you my big, whole Vim profile, ignore all this garbage. We're interested in two lines right here. Allow project-specific vimrcs with makeprog. It's the set execrc thing and then the set secure. And these two things, these two options, allow you to have project-specific vimrcs. Now, you got to be a little bit careful because Vim will parse any vimrc that's in a directory. So there are security implications associated with that. So you have to think that through. Look these options up before you just embrace this lifestyle. But this is how I do this, and I'm careful in terms of what I'm doing with Vim. So I make this adult decision to allow vimrcs to get parsed into Vim. So with that in mind, I have this file, this vimrc file that's sitting in the base of this directory, and then anything that I vim into here, I'll show off one more plugin here. It's called Control P, and it's a fuzzy file open for Vim. Very helpful on the day-to-day for actually getting into something, getting into a file that you don't know where it is, or you just know its name, or you know two parts of its name. It works the same way that repaz does for change directory, except for it works in Vim for opening files. So I'm going to type test.cpp, which is the thing that I was just working on. It brings it up. Here I am. So now I'm going to use that command to make the program that I'm currently in, and it's colon make, and it's going to, like I said, pipe that compiler string out to the terminal, run it, bring it back, parse it, give the error message. So that did it. However, you notice it like flashed over to the terminal. It did some weird stuff. It makes you hit enter a few times. There is a plugin called Vim Dispatch, which will be in the public just at the end, that makes this all a much nicer experience. So I'm going to show you how that works. It's essentially analogous with how normal make works, except for it puts it in a little buffer at the bottom of the screen instead of sending you out, making you hit enter a bunch of times. So when I use capital M make from Vim Dispatch, I hit enter. It does the same thing, except for it gives a little status line at the bottom that says, hey, this was successful. See, it's got all this stuff expanded with the file names and all that good stuff. So if I introduce some artificial errors in here, some error, I put some colons at the end of it so that it will continue parsing in C++ instead of just barfing and stopping on the first error. If I compile this, it's going to give me this buffer at the bottom. Now, don't worry. I have the font size set to like 40 on this terminal. It's not normally this big. It's relatively small at the bottom of your screen. But so you can see in this video, this is how this looks right here. So there's two ways to deal with this thing at the bottom. This is the quick fix list that I was talking about. One way is to get into that window. This is a Vim window. So it's different from tmux. It's different than your terminal. This is the Vim window at the bottom. So how do you get into that buffer? One way is hit Control W, Control W. And hold on, my little thing that shows key bindings has stopped running and crashed for some reason because it's some guy's software. So let me restart that really quickly. Hopefully I can cut this part out, but maybe it's fast enough that I won't need to. All right, perfect. So it's back up and running. So I hit Control W to come into this buffer at the bottom. Now, if I move around with my arrow keys or my HJKL, I'm down here. If I hit enter on this error at test.cpp line 13, it will take me there in my Vim buffer. And it puts me there automatically. I can delete that, hit save, hit make again. And here now I have the one error. I can hit Control W, and here I am down here. I can hit enter. It will take me there, delete it, save, make with no typos. And then here I am, success. And this thing will shrink down and close. Here we are. So that's not normally the way that I interact with it. That was just to show you there is a way to get into that buffer and like navigate around in it if you need to. If the error list's long and you need to get to something that you know is good, maybe you go Control W, get in there and start navigating around in there. But in general, there's a shortcut. If you want to go to the first error, it's :cc. And here I am, my cursor's there. Or if you want to go to the next one, it's CN. If you want to go to the one after, if you want to go to the one previous, it's CP. If you want to close this thing, it's close. So there we have it. I'm going to delete this, rerun it, success. Okay. Now I'm going to show you how to run the binary that this produced, which is build.test or build/test, and show you the output inside of Vim here. In the same plugin, Vim Dispatch, there's something called the dispatch command. And you guessed it, it's going to run this binary in the terminal and give you the stuff back in a little buffer at the bottom. So if I type dispatch test, or excuse me, build test, here it is. It's 8 and 5. That's what this does. It just spits that stuff out to cout. Fantastic. I can type close to close that thing again. If I'm going to run this over and over again, and I don't want to type build test over and over again, I can type focus build test, and it will set dispatch's default arguments to what I just typed. So now I can type :d tab enter, and it will run it really quickly. So your cycle goes down by many keystrokes per once you set the focus. You've got the make prog string set in the Vim variable inside your vimrc. Everything kind of starts flowing really quickly. So that's it. That's the whole thing. I use Google test, or there's like Ruby unit tests or JavaScript unit tests. All this stuff can be used in this way. And it makes it all really fast and within the context of Vim, and doesn't like, you're not like bending over backwards to make it work. And the core pieces of that is really that Vim dispatch plugin and some knowledge of how Vim's make system works inside. So the next thing I want to show is compile code specific, but it can be, in another world, it might be a JavaScript debugger, but it's how I do C++ debugging in a Linux-like environment with a terminal. And what is this the smallest subset of tools that I do to use to get that done? So my promise is we're going to look at GDB and we're going to look at the minimal subset of debugger commands and a GDB init file to get you productive and moving forward in a way that's not like extremely painful to use, which default GDB tends to be kind of extremely painful unless you know it and have used it for like years and years. And even if you have, this is going to help you because you're going to get more context and you're going to understand what's happening a little bit easier. You're not going to keep so much stuff in your head. You can be able to look at it on the screen. So this is where um, that second tmux window comes in handy. Is sometimes I got to go debug this thing. So I'm going to go in this build directory. We're going to look at this quickly. So test, if I run this, it's 8.5, great. So I run GDB. Well, let me show you my GDB init file really quickly. It's 3 lines. It's not too complicated. 2 lines here because I turned one piece off, but I just set the disassembly flavor to Intel instead of AT&T. Completely your preference. Doesn't really matter. I set pretty print on, which basically just means like in the same way you want to pretty print some JSON with, you know, value here, and have nice white space at the beginning and the end. This does the same thing in GDB when you print variables out. It's the only 2 things I really deal with. The last one I put in here is TUI enable, and I'll show you why. This is text user interface. I'm going to delete this for now and do it when we're in GDB to show you what it looks like normally and why I do it. So I run GDB test. It reads the symbols from test because we had the compile flags on GCC to tell you to tell it to emit debug symbols. It does that. We can set a breakpoint on main, and I'll go through these commands in a second, but I want to get you to the basic running program. It runs to main and breaks and stops. So you'll notice that in GDB by default, it shows literally 1 line, which is a little bit annoying out of the stack frame. If you type BT, it shows you the backtrace. In this case, it's 1 frame because we're inside the main function. There's nothing above or below. We're not inside a function outside of main. So this is a little bit annoying. There's a command list that will show you the source here, and this will match the debug symbols that we compiled into the binary with the source file, and it'll show you this stuff. Again, it doesn't show you which line of execution we're on. We're actually right here. It doesn't show you where the breakpoints are. You have to use separate commands for all this stuff. You got to type, for instance, info breakpoints to show you where the breakpoints are. You have to say F to show you where the thing is actually stopped. You have to say BT to show you where the backtrace actually is, like where you are in the call stack. Each individual thing can be learned and used, but it's much nicer if you use what's called the text user interface, in my opinion. So TUI is a thing I have in my GDB init by default, and when you enable it, it shows you a slightly different screen. Shows you the source on top by default. It shows you where the breakpoints are. It shows you the line numbers, and it shows you what your current line of execution is. Super helpful stuff. The only other parts of TUI that I use is commands called layout. If you type help layout, it'll show you what the different things are. The ones that I tend to use are really source and ASM, and then very occasionally I need to look at the registers. So if I type layout ASM, it's going to show me the assembly language instead of it's not decompiled, but just the linked symbols back to the source file. You're going to be able to step instruction by instruction in this mode and actually maintain the context. If you were to do this with vanilla GDB with no TUI, you'd have to type disassembly or disassemble, I think, and then you type that out and it would show you the entire function's disassembly. And again, it's a lot like the list command, whereas this shows you exactly where the breakpoint is. You can step piece by piece and it highlights it, which is really nice. And then you can look at the registers with layout reg. So it'll put both of them here. You can also look at the registers in normal GDB. You just use a command to do it. But this continuously updates the screen. So very nice, convenient, and in my opinion, fairly modern debugging experience. And it's just so much better. So with that in mind, I'm going to just set layout source, which is like the default thing, and we'll show you the other subset of commands that I use every day. So one of them is to deal with breakpoints. There's really 3 things I do with breakpoints. I list them, I set them, and I delete them. That's it, right? So to list them, I showed it earlier, it's info breakpoints. And this is going to have a number here, and you can do things like delete them based on this number or delete them based on where they are or the function they're at and things like that as well. It uses any combination of those things to get that done. The other way you can set a breakpoint by saying break and then a function name. You can say break and then a file name with a line number. Or if you are in this current frame, as we are inside test.cpp, if I say break 9, it will set a breakpoint at 9. And here it is. It shows it in there. Every once in a while, by the way, the TUI's UI gets messed up. And this is usually when you print something to standard out. Just know that the way to fix the UI or redraw it forces a redraw, is Control L. So Control L. You just kind of got to remember that one. So we showed you how to set breakpoints 3 different ways. Delete breakpoints. Well, you delete breakpoints. Delete all breakpoints. Yes. There's one other command, and I think it's called clear. Help clear. Clear a breakpoint at a specific location. So clear is the way you do that. I actually don't do that often. So it's kind of weird. I'm not like setting breakpoints and deleting breakpoints all the time. I'm just kind of like, I use it as a place to enter the program and then start stepping through. So breakpoints out of the way. Now, how do you move around the program? The first thing is R. It will either restart or run the program the first time, and it will ask you if you're restarting it. I'm going to restart it. Oh, it actually just went right on through. Let me break it main again, restart it. So it's broken at main. You can see now because I printed a few times, it's like kind of screwing things up. I had to hit Control L and it fixes it, redraws it. That's fine. So run. That's the first one. The next thing is step over. Step over is N. Pretty straightforward. Next. Step in is S. So it didn't do anything different there, but in this particular case, because we have a function here that we're running, sum, if I hit S, it will step into the function. If I hit N, it will step over the function. So I'm going to hit S. It's going to take us up to the sum function. The opposite motion, step out, is fin or finish, I think it's short for. But if you type fin, it will pop you out of the call stack and put you to the same spot. Sometimes you need to do this specifically with, like, for instance, if you have standard library stuff, for instance, a function, let's say void thing, string thing, or T1, you just make this thing print a string. Okay, that's a great function. Do we have a standard string? We don't. We're gonna put it in. Don't ever do this, by the way. Don't say using standard namespace standard in the global. People get mad at you. But yeah, we're gonna do this here. I'm going to call this with a string literal. String literal. And what's going to happen actually is when we execute this line of code, it's actually going to create a string object from the string literal on the fly. So when you step into this thing, you think you're going to be stepping into this function call, but you're actually going to be stepping into the constructor of the string object first. You don't really want to be in the standard library. It's a bunch of gobbledygook. You're going to take a million steps to get out of there. I'm going to show you what that fin command is good for. So I just made this thing. I'm going to come back here. I'm going to rerun this. I'm going to clear breakpoints. I don't know what's going on. I can't remember what happened. I'm going to break it main again. I'm going to run it. Here we are. So here's the updated source. I'm going to hit next, next, next. Redraw this thing. I'm going to hit step. You're going to see it step into the standard library for the string constructor. Here we are. A bunch of crazy stuff. I'm going to hit fin. It pulls me out. I'm going to hit step again. It's going to take me into my actual function. So that's where that stuff is helpful. The only other command I use for moving around, I don't use reversible debugging or anything else crazy like that. I generally just use step instruction. And that's in case I'm looking at something that requires me to look at the assembly. SI will take you one assembly instruction at a time. And that's it. So we've come to the end of our mini GDB tutorial. This is like the nugget of commands you need to get useful when you're using GDB. The last thing I do is print variables. So there's really 3 ways that I do this. P, which is print, and I can't remember what I'm looking at. Okay, so next. So if I want to print the value of T1, I say PT1. And here we are. It's some goofy looking standard string object. It's got a bunch of stuff. Again, when this is like not 5,000 size font, this actually works pretty well. But having this pretty printed when it's 5,000 size font is a little goofy. But anyway, this is the actual local buffer that holds the string literal in it, and it's a bunch of other standard library gobbledygook. The only other thing that I really do is display. And this will, every time you step, it will display the value of T1. So if I were to be changing this, it would be helpful, but it's not really. So let me rerun this thing and I'll show you what I mean by that. So I'm at main. I actually changed the value of 2 here. So if I say display A, at the start it's uninitialized, so it's a bunch of garbage values. I'm going to hit next, next. Now it's 5. Next, next. Now it's 2. And I'm going to hit Control L to redraw because, or one more next. It's 2 now. So if you have a local variable that you want to have a watch on, basically, that's one way to do it. It's the equivalent of the modern debuggers, watch locals tab or whatever. That's it. That's all I use in GDB. So we talked about TUI mode, some layout commands for TUI mode, how to deal with breakpoints, movement, and printing, and that's basically it. The last thing I want to do is show you that all this stuff that we just talked about works with a slightly larger project using CMake. So I have another project over here called Combat. It has a CMake file in it that's like the build file. It has a bunch of compiler options in here, but the real thing is it has a custom version of LLVM project for sanitizers for the Clang the Clang compiler. So I could do memory sanitizers and address sanitizers and thread sanitizers and all that kind of good stuff. It has links to the Node C++ add-on API. It has Google Test and Google Benchmark attached to it down here, which are they're also using CMake files. So it's relatively easy to integrate them by just adding a subdirectory. And then I have a vimrc in the base of this file that uses a make file that is generated by CMake. So in CMake, you generally use out of build or out of tree build folders. You run CMake in that folder and it creates a bunch of make files for you to do various things. This thing just runs that make file inside that build folder with 16 cores. I think it's some sort of concurrency number that makes the build run faster on a computer that has a nice processor. So we do this. This let make prog formation is just a different way to specify the make prog variable so that you can use these quotes and have unescaped white space. Just a convenience. It does the exact same thing as far as I know. There might be subtle differences, but it's beyond my capabilities to understand what they are. So if I open this up and go on my tests, here I am. I've got a test here. I can run make, and that was extremely fast because it's not a clean build. So let's actually make a clean build here to show you what's going on. Go inside the debug build, make clean. I'll show you what this looks like. It just has a make file that we made with this command. Nothing's fancy. That's it. The build files got written right here. I'll print it again. So this make file has make clean in it and all the rest of it. I'll just cat that real quick so you can see what it looks like. Oops. Blah, blah, blah. We switch back to our thing. We run make again. It's going to do a clean build. You're going to be able to see this thing run. And it's making all of those external libraries and linking stuff together. And it's relatively small project as large projects go, but you can see how this scales up and does a pretty decent job of it. You can still be editing your file and doing all kinds of stuff. So that's one good thing about CMake, or excuse me, Vim dispatch, is it doesn't like screw you over. Though I seem to have a bug here, actually. It would like screwed up the buffer a little bit. But anyway, I had never done that really, but I assumed it worked. You can still move around, but clearly you need to redraw Vim, or Vim needs to redraw after that buffer disappears like that. Let's incorporate an error in here. So a test error of some kind, just a syntax error to show you what it looks like. We're going to make. It's going to fail, and it does the exact same thing it does on the other project. I'm going to type :cc. It's going to take me right there, or maybe I wasn't there. :cc will take me right there. I can delete it, save, make, and this should succeed, and it should close, and it does. And then dispatch, in this particular case, this makes a binary. I'll show you where it is really quickly. It's inside test. Got this test binary. It's running some Google tests. Some of them are failing. That's fine. We can run dispatch initially with build, debug, test, tests, and it runs it. There's your Google test. If I do that with focus, dispatch will then default to that test thing. I'm going to close that for now. And that's it. It works with a bigger project, and the whole workflow scales up relatively well. The reason I do this, the whole core of it, is because I want to get as close to the tools as I possibly can. Things like GDB have debugger protocols like MI, I think one of them's called, and it's used in things like VS Code to connect to the debugger. Those things are relatively brittle, and it really helps to know the commands and mean touch the software with your own hands. Even if later you decide to move on to an IDE, that knowledge never leaves you, which I think is extremely valuable. So, anyway, that's it. That's the whole thing. Thanks. Thank you. Goodbye. Have a nice day.